Hello everyone, my name is Cyril Sadowski and I am a lead AI engineer at Deutsche Telekom IT Solutions Slovakia. And today I would like to talk to you about real-world AI applications for enterprises. But before I start, someone once told me that to engage the audience I should tell a joke. So here I go. I told my wife that she was drawing her eyebrows too high. She looked surprised. Okay, so now that we are engaged, let's analyze the simple mathematical formula starting from the left side where theta star equals. I have no idea what this actually means. I just gave ChatGPT the instruction to generate something really complicated looking. I really think that this has no meaning. But what does have some meaning, and very bleak meaning, is this. MIT report, 95% of AI pilots fail. By the way, guys, can I get, I don't see my slides here. Okay, so about 95% of AI pilots fail. Thank you. So let's put it in exact terms. Just in year 2025, about $400 billion will be invested in artificial intelligence. So if I'm counting right, that's $380 billion down the drain, right? So do you know what I could buy for $380 billion? Something nice, like the whole of Deutsche Telekom and then some. So this is what we are actually facing. Now I would like to address the elephant in the room. Who we are? CEOs. What do we want? AI. AI to do what? We don't know. When do we want it? Right now. I certainly hope I won't lose my job after this talk. But anyway, I am in this really unique position where I am also a leader or a manager. I have about a dozen engineers reporting directly to me, but I am also an engineer. So, as I said, I have this unique, some might say unfortunate position where I see both sides. I sit in the intersection, and I can tell you that this is not only about CEOs, this is not only about leaders, but this is also about engineers. CEOs want results. We all have this inner feeling that maybe we should be able to deliver something interesting with something that can think similarly to us. But on the other hand, engineers were never trained to understand artificial intelligence and machine learning world. So why do so many AI initiatives fail? In my opinion, it's about AI mindset. It's organizational capability you build, not buy. So do you remember that painful transition from waterfall to agile mindset? So when I came and started to work for Deutsche Telekom in 2020, there was already this change on the way. We were transforming from a kind of your typical waterfall organization, these rigid structures, into agile mindset. And many of you who have adopted agile mindset, you know that this is not about processes. This is not about bureaucracy. This is about how we are thinking. By agile, you mean waterfall in sprints. Unfortunately, we still face this kind of way of thinking. But to adopt AI mindset, I would like to describe to you our own journey. Because beforehand, before we started working on artificial intelligence projects, we were just simple software engineers. And we had to transform how we actually think. So our story, our journey, our story. The impediment to action advances action. What stands in the way becomes the way. Marcus Aurelius. And let me tell you, there are many obstacles in the way. Let's start with the first one. Augmentation versus automation. So augmentation, this is your typical tools like, ChatGPT, GitHub Copilot. So this is to a certain extent already a solved problem, although I have no doubts that the tooling, the augmentation, will evolve rapidly also thanks to a thing called Model Context Protocol by Anthropic. What I want to talk today about is stochasticity. Automation. Looked at the wrong slide. So automation. So automation is basically taking the engine, which is, for example, GPT-5 or Claude Sonnet 4.0 by Anthropic or Gemini 2.5 by Google, taking these engines, these thinking engines, and integrating them into your own workflows, into your own organizational processes, into your software, into your applications. Now, this is the stochasticity. So, the next obstacle in the way of transforming our mindset is determinism versus stochasticity. So, determinism. In the 19th century, scientists and physicists actually believed that if we knew all positions and all velocities of all particles in the whole universe, we could essentially compute the future. We could predict the future. Now, this in the beginning of the 20th century came falling down because along came the quantum theory, quantum mechanics. And what we realized that the world around us actually is fuzzy. It's not chaotic per se, but it's not quite predictable. So this is the fundamental law of our universe. And what I believe, I really believe in this, is that stochasticity is the nature of our universe, and modern artificial intelligence, modern machine learning approaches will allow us to embrace this stochasticity, I would say the underlying reality of our universe. Now, we talk about obstacles, but we have to actually have people who are able to utilize this AI mindset. So as I said, originally I was a software engineer. So software engineers, essentially following Alan Turing's way of thinking, are implementing algorithms. So the exact input will yield the exact same output. So this is your typical algorithm. But someone or something have to provide the inputs. That might be actually artificial intelligence, but more on that a little bit later. So we decided to create this special position, which is called AI engineer. And AI engineer, on top of their software development skills, should also know something, although not everything, from the world of data science. So like understanding the data, preparing the data, transforming the data, loading the data, and being able to integrate artificial intelligence processes directly into your applications. Now, maybe you have heard about full-stack developers. So these are people who know their databases, backend, frontend, maybe something about DevOps. So we originally thought that we could call this AI engineer fuller than full-stack developer, but it doesn't quite roll off the tongue, so we decided for AI engineer. So, everything versus pain point. And this is touching back on the meme about CEOs. We in our organizations have to really know and understand the critical paths and critical potential failure points where we want to implement artificial intelligence. And for that, we need your engineers and your domain experts. So our pain point, data extraction from messy drawings. So as you can imagine, Deutsche Telekom has thousands of different antenna sites. And these sites are defined by technical drawings. To be able to understand such a technical drawing is a very difficult task because you have your engineers who create these technical drawings, but every single person has a different approach. And it's really difficult to create one single standard, to create one single structure. Just to give you an example, this is just a table from such a technical drawing. I know you cannot see the details, and that's actually the point. So just tables in such technical drawings are extremely complicated. This is actually not a real table. I couldn't show that due to confidentiality reasons, but this is automobile legend. We call it automobile legend, not antenna legend, and this is basically fake, right? But we are simulating what kind of the real table looks like. So how did we decide to tackle this problem? Well, of course, in a scientific, experimental, and iterative approach. We found one paper, one study by Google called Sample, Scrutinize, and Scale, and we decided to follow its instructions and its findings because we thought that Google's findings might be relevant to us. So let's start with the machine learning approach. So originally, and this is roughly speaking, 1/3 of the time was spent on analyzing the data. That's data science. 1/3 of the time, originally, by data scientists and data engineers, was spent on data engineering, so basically preparing the data. And again, very roughly speaking, 1/3 of the time was spent on modeling. So you could prepare your statistical models or deep learning models. But essentially, this was the way how, the process how originally machine learning was done, or still is done. Our approach changed a little bit, or how we approach our problem. We spent about 45% time on data science, 45% time on data engineering, and about 10% time on modeling. So you can see here that we saved about 20% of the time. That's a lot. But it's not like you can send to the AI something and the AI will then magically come up with some results, right? So this is just to give everyone a perspective on that we are, thanks to modern models like GPT-5 and Gemini, etc., we are able to save time, but it's not like 95% of the time. So bearing that in mind, this is the experiment itself. The experiment took about 1 month to complete. But remember, we had to have data prepared. That means we spent about 4 months, 5-people team to essentially prepare the data. So before we could even run the experiment, we spent about 4 months just to prepare the data. The experiment is rather simple, although it looks complicated. So what we do, we take this table, right? And we generate 50 different candidates for that particular table. So we send, for example, to model GPT-5 or Gemini, that particular table, and then we ask the AI to generate candidates, what it thinks the table represents. Then we automatically reject about 27% of the candidates because they don't have a valid structure. And then we analyze the 73% candidates left with the AI itself. So imagine that we have like 20 JSONs, 20 candidates from that particular table, and we let the AI to analyze its own results, which sounds really weird. So again, just to give you an idea, future learning, what it means. So you can utilize future learning even today with your artificial intelligence. So let me give you a sequence. 1, 3, 5, 7, and the next number is 9. Yes, thank you. So this is exactly what the AI is capable to do. You can show it sequences, examples of the stuff you want to generate, and the AI kind of learns your thinking and can generate what you actually want. So in the image, there is an image of automobile legend. Your task is to extract data from automobile legend table as accurately as possible. AI self-judging. So this is the part where we let the AI to judge its own outputs. And I actually prepared a explaining schematic how this works. So please concentrate. This is quite complicated. Right. So, is it worth it? The big question, right? So let me give you some numbers. At 0.95/0.98 thresholds, the success rate improved from 90% to 97%. Is that good? I don't know. What is the threshold to which you are comparing? So it's like Hitchhiker's Guide to the Galaxy, where they asked, you know, the all-knowing or all-powerful or whatever computer, what is the answer to the ultimate question of life, universe, etc. And the answer, of course, was 42. So this is essentially what many organizations are doing. Although we have a lot of AI pilots and initiatives, etc. But what is the question that we are trying to answer? Google's SLAs are 99.99%. So about 99.99% of the time, Google Cloud Platform will be up and running. So comparing to the 97%, although the increase is huge by 7%, it's not good enough. Yep. But human reliability is about 95%. So if you give complicated structured data to human beings and let them extract data from these documents, they make about 5 mistakes per 100 data points. So suddenly, then increasing from 90 to 97% is making our system more reliable than human beings. Yay! So, okay, so per case cost is about $25. So is that worth it? Again, I don't know. How much responsibility are we willing to give the AI? Human and AI cognitive capabilities are equalizing. It's more about who will take the responsibility. And if we, as leaders, engineers, if we want to take the responsibility of implementing AI systems, we should essentially answer these 3 questions. Would an expert do it cheaper? Would an expert do it more reliably? And the biggest question, at least for our project, is, are there even experts available? So many times it happens that there are no budget constraints. There just isn't enough people. And we all know that this problem is not going away. It will be only worse. So the 25 cost per case, it of course depends on your own needs, but I would argue that for us even $500 per case would be efficient, because we are not able to find experts on the market to do the job, right? Before I end this talk, I have to take a sip. I want to give you a way how to think about implementing artificial intelligence into your processes, into your applications. This is kind of a meta way how you can think about implementing AI. So we have data. Oop, what happened there? I pressed a wrong button probably. Can you see the screen still? Kind of. Thank you. Okay, so of course we work with data. Then we somehow process the data, and now comes the important part, the AI decision. So as I said before, originally with our Turing algorithms, your typical algorithms, we essentially were not able to make decisions on fuzzy data, right? So to give you an example, our system is capable of telling us whether its own outputs are good enough, they have good enough structure, they contain good enough data. So if the AI decides that the output from the table was good, we continue with our processing. But if the AI decides that no, the outputs from what we generate from our tables, the JSONs, are not reliable enough, we then move to human in the loop circle right here. And this is also what we have to get used to. With artificial intelligence, as I said before, human and AI cognitive capabilities are equalizing. We have to get used to the idea that we as human beings will become parts of the pipeline. This is for a different talk. Didem will talk about this, so please come and listen to her talk. This will have different implications, but for this purpose, for this talk, this is something that we have to take into account. So AI decides, we do further processing or involve humans, and then we generate data. And this pipeline, you see that circle processing over there and processing over there. That's why I said this is a meta pipeline, because this processing part can actually be this pipeline itself, right? So this is what I'm talking about. This is why I'm saying that it's kind of meta thinking about AI implementation. Okay, so the team. Martin Matis, me, Cyril Sadovský, Tomáš Miščík, Ivana Hojdová, and Tomáš Borgoň. If you want to know more, we created a 75-page report. You can find it right here. It's kind of a blueprint how to utilize and implement artificial intelligence into your organizations. And I know that 75 pages can be quite a long read. No, not everyone has the time. So we created kind of a introduction, introductory paragraph, which we call executive summary. And it's about 2 pages long. And this executive summary will give you a general idea about what we've done and how you can approach your own implementation of artificial intelligence into your own processes and into your companies. We have a stand right over there across the hall. So you can come and talk to us. We have a lot of data and a lot of details. We will bore you to death, so please come. And with that, thank you very much, and thank you for your attention.